All right. So in these last recordings, we're solving rational equations where we have a variable in the denominator. Some of the tricks or the strategies are to use your least common denominator to clear out fractions. On this one, it's a word problem where we're solving a work related situation. It says it takes a smaller hose 4 times as long to fill a certain swimming pool as it does a longer hose. So we've got your small hose and you've got your long hose, and then together both of them would could do the job in 25 minutes. So how long will it take the larger hose to fill the pool all by itself? So we're going to use the idea of like ratios. And so just over here to the side. So what the task is doesn't really matter. We can just say that there's just a job that needs to be done. And the job here would be to fill the pool completely. And then that is with respect to some amount of time. Okay, so we're going to just keep our ratios kind of like in this sort of format where it takes how long does it take to do one job. Now, we're going to build an equation, and going to like what their question is how long will it take the large hose to do the pool by itself. So what we'll do is we'll let x be the time, right? Because we're looking for the time. Let x be uh, large the large hose time to fill up the pool all by itself. Okay. And so now when we come here, we're told that the smaller hose will take 4 times as long. So here's my this one pool, the large pool. Okay, or maybe I'll even do it this way. Okay, here's the large guy. Here's the small guy, the small hose. And for the pool, it can do the one job all by itself in X amount of time. Now, for the small hose, it can do the one job, but it takes 4 times longer to be able to do it. Now, if you add their effort together, right, we're told that they can do the job together, the one job together in 25 minutes. And now this is what we need to solve. Now I do have down here that it should come out to be 31.25 minutes. Again, if we want to clear the fractions, we can do this where looking at the denominators, we've got a 4, an x, and a 25. So the least common denominator would be, you can think of it as 4 times x times 25, which would be 100x. And so we can take our left side, we can take our right side, and we can multiply it all by 100x. And there's other ways to do it. This is just trying to use something that I've used in, strategy wise and other instances. And so whenever you do this, you're going to multiply these two together, which is going to give you 100x over 4x. But do you see that we're going to be able to like reduce and get rid of those x's? Now you're also multiplying these two together, which is going to give you 100x over x. And then you're going to multiply these two together. Again, numerator with numerator, denominator with denominator. So you're going to have 100x over 25. Now the fun part. These x's slash out or divide. These slash out, divide. 100 over 4 is 25. Plus 100. And then over here, we've got still an x, but we've got the 100 divided by 25, which is 4. And so now we start adding things up. This is 125. This is 4x, and now we divide our 4. And so again, 125 divided by 4 equals 31.25. And so that's where this answer came from. Again, x means that it'll take 31.25 minutes for the large hose to do the job by itself. All right, so again, clearing fractions. You could also do another strategy where you make common denominators. Multiply this by 4, multiply this by 4. That might be another way to go, but this is clearing fractions. All right, hope this helps.